So thank you very much for the warm welcome and the invitation. It is a pleasure for being here and talking to you about software-specific issues of intellectual property. My background, I'm a computer scientist, and I work now as a patent attorney at Boehmert&Boehmert. This is a law firm which is completely focused on intellectual property in all areas. And since I'm a computer scientist, I lead a group which is focused on protecting of software. This starts from copyright protection and goes to patents and all various areas. Software is quite specific, and I would therefore like to introduce various ideas and aspects to you, because intellectual property protection is very important if you want to start with an initial piece of code and you want to develop an own idea, bring it into apps or systems, and then distribute it on the market. So my talk will be structured as follows. First of all, I will introduce software and the problems with software, or the problems we have with the traditional approach of software in intellectual property systems. I will talk about the different intellectual property rights. And then I would like to move to patenting, because I think that this is the most interesting issue with regard to software. And I would like to present to you the approach of the European Patent Office on patenting of software. Thereafter, I will focus on two very important areas right now, which we encounter from our practice, and this is patenting of machine learning methods, or colloquial artificial intelligence, and patenting of blockchain technologies. In the end, I will give some practical issues, how patenting or how software could be protected using the various intellectual property rights. So, since I don't know how much you are into intellectual property rights, I would like to give a brief overview of the traditional intellectual property system. In the general or typical approaches, dedicated rights have been created for individual products. We have therefore created technical rights for technical inventions, which have been mainly from like machines, or if we have such pointer devices or whatever. So technical inventions. There mainly patents are granted. On the other hand, there are protective rights that go further, not only for technical inventions, but also for creations of the mind or for aesthetical creations. For example, designs, they can also be protected using individual rights. And last but not least, we have copyright protection. Copyright was mainly, in the beginning, directed again at aesthetic creations, for example, paintings or some literary works. And maybe this is the reason why software initially has been protected using copyrights only, or it is mainly grouped in this area. Because software is very often, it's a piece of code that is written, and this piece of code resembles maybe the work of an author, and this is the reason why copyright has been chosen as the primary right. And indeed, we have right now dedicated protection for computer programs and code using copyright. But it's for a purpose that copyright and patents are in these different parts of this graph, because copyright only protects a copy. So if you have created a piece of software code, a copy of this code will be protected. But think of one example. You read a piece of software, you recognize the idea that's in the piece of software, encoded in the piece of software, and you sit down and reprogram it. This reprogrammed software code will no longer be protected under copyright. So we see, even from this traditional approach of there is a strong protection for a piece of code, this may not be sufficient because, for example, reprogramming of code is no longer protected. On the other hand, we have patents. Patents do not protect a single device, but they protect the idea, the general invention, which is behind this device. So even if something changes with the device, it will still be protected by a patent. But software or it is an open question whether software is really a technical invention. So patents do not really apply completely to software. But we will see later on how this can be handled and why I believe that patents are a very important protective right for software, but not the exclusive right, but something which extends the possibilities of protecting software. So why is it important? Software is changing and innovation is changing. Innovation is moving from single products, which are tangible, which you can see and touch, towards the digital domain. Moreover, software has various facets and various aspects that are embodied in the software. In traditional, I would say, industry, we had individual machines and there were innovation in these machines. But right now we are moving towards machines that start communicating with each other, that start exchanging data with each other using cloud technology. And these machines are very often controlled by software. So the innovation is not necessarily within the robot or the car or whatever, but it's the software within the machine that bears the innovation. Further, in this networked environment, there is even a further transfer. So we are moving away from the machines towards the networked environment. And there is something which is right now termed artificial intelligence, or this morning I heard the word artificial stupidity. Maybe it's the better word for it. So it's machine learning, something which recognizes all the data and which analyzes the data from the individual machines. And this data is then fed back to the individual devices. And the innovation is where? Very often it's here. So it's in the digital domain. Furthermore, another interesting approach or issue is that these transactions are governed by further systems, by blockchains namely, which control which transactions took place in the digital domain. So you see, we are moving away from a single piece of code, software that the programmer has programmed, which could be protected under copyright, towards something where software is the major part or the essential part and controls entire systems and networks. And there, apparently, we need something more to protect the piece of software which is not only copyright, but which has more to it. Then another issue with the traditional piece of, or with the traditional intellectual property systems. Typically, there was like one invention, one aesthetic creation, and this was protected by one dedicated intellectual property right. Nowadays, how can we protect software? Because software is much more complicated. We have several authors that work on a piece of code. This is not only done locally on one machine, but this is typically also distributed online. We have then, after it has been coded, the assembly and compilation process, where various libraries are included. They may be also governed by different licenses. And then we have a distribution, a classical distribution using some media or in a cloud. And finally, all this final product is then distributed, pushed or pulled or downloaded to individual devices. So we see here there's a complexity which moves from the initial notion of one creator, one author, where we have a straightforward distribution route, and where we could say that there is for one innovation, one classical intellectual property right, towards something which software is right now. We have many actors, various distribution routes, and we need a more comprehensive protection. But of course the question will arise, because I said in the beginning that patents are for technical inventions only. So is software really technical? Or what's about this technical aspects that's with software? And we will discuss this later on during the presentation. But so far, I have to conclude that software requires several intellectual property rights for its protection. Here I've depicted the most important intellectual property rights. And this is to encourage everybody who has to do with software, not thinking only on copyright, which is really important, but also on other intellectual property rights in this area that are also important. So first of all, as said, patents. Patents and software. I have already said patents are for technical ideas. Can we protect patents, software using patents? The answer is yes, and this is clearly also the approach which is taken. But strictly speaking, software as such is very often excluded from patentability. So what we are protecting using patents is the underlying technical concepts. The inventor or the programmer had an idea how to control the devices, how to control the computer, how to assemble all these individual aspects together in software. And these underlying technical ideas have then been implemented in software. And the underlying ideas, if they are technical, can be protected. Here you see an example of an application of Apple, and this even addresses the copy and paste between devices. So a control of multiple devices where you can accomplish certain tasks can be patentable. Now let's move to the next protective right, copyright. And I already said, of course, you can protect software using copyright. It's a very important issue. And we will have also today presentations on open source and free software and open source software. And I think that this is something which is complementary. So the one does not exclude the other. And you should think of protecting software using copyright, and there is even an automatically granted copyright as soon as a computer program has been written. So copyright, yes. What's with the next one? Trademarks. This is very often forgotten. It's very often not protected, but each and every computer programmer has a name for a computer program. An app has a name. Maybe logos have been created. So software can even be protected using trademarks. You see this, of course, Intel, Microsoft, and the like, they have protection on their trademarks. The next one would be designs. This is an important protective right which protects the outer appearance of products. For example, this pointer device could be made subject of a design application. Software also has an outer appearance. First of all, generally in the area, you could protect the appearance of, for example, mobile devices or smartphones, but also graphical user interfaces. A particular look and feel of a software can be protected using designs. And you see here an application from Microsoft, a particular animated display screen. We need not to discuss whether this is a nice design or not, but it can be protected. And this is a very interesting thing. Designs are very registered. You can look up them in the registers, and then very often you see the new design of a user interface, for example. You will see then the new design of the new Apple products and the like. And this is often something which is not done with regard to software, but clearly should be addressed as soon as there is some particulars about the design or outer appearance. Last but not least, trade secrets, which also form an important part of software protection. It's a kind of not really an intellectual property right, because you are not entitled to a particular right. But on the other hand, with regard to software, where sometimes it's better to keep certain parts secret and not protecting them at all. So far for the individual rights. And in my opinion, it should always be comprehensively taken, so not only focusing on the traditional copyright, but taking in particular into consideration patents and all the other protective rights, because this will then create a comprehensive protection and protects the own initial development from the start of an app, for example, towards the distribution in the market. So let's now move to patenting of software. This will be the main focus of this presentation. I have already said initially that there is a kind of discrepancy, because code is very often regarded as a piece of literal work or a kind of abstract processing, algorithmic processing, or this is abstract processing, and patents are granted to technical inventions. And initially, this has been regarded as a discrepancy. But as you have seen, there is a strong need of protecting these ideas, the innovation that moved to the digital domain. So the European Patent Office has adopted a very, I would say, good approach for assessing whether the underlying technical concepts can be patented by first establishing, this has been termed the so-called computer-implemented inventions, which can be patented. So if you see the notion of a software patent, you will never get a patent on a piece of code only. The piece of code will still be protected using copyright, and you will never get a patent on this piece of code. So patents on software will always be focused on the underlying technical concepts. And the European Patent Office has established a two hurdles approach, where in the first step it is established whether the invention has technical character at all. Think, for example, of a piece of software or an app that only focuses on, for example, a business method, implementation of a business method, trading, stock markets, or analyzing of stock market courses, or well, simply something which has no technical implication at all. The European Patent Office will not grant a patent on such pieces of software, on such code, because there is no underlying technical idea. So first approach is determination whether there is a technical character at all. And in the second step, because undeniably there will be always a combination of having software code, which is more abstract or which is not technical, and on the other hand, having software code which has a technical implication. And in this area, the European Patent Office will kind of dissect the invention, separate the parts that have no technical implication, and only have a look on the parts that have a technical implication, the so-called technical features, and then it will grant a patent only on these technical parts. That's the approach of the European Patent Office. But of course, and maybe you were wondering, but what's a technical feature that I'm talking about, or what's the underlying technical concept? And this I would like to show you on such a graph where we see technical features in code. You have here the general approach of a computer with some input and some output. And the software is running in the computer, of course. So this piece of software should be the invention, and we have the question, or we have to answer the question, whether this piece of software can be patented. If the software only runs in the computer, has no interaction with any parts, and only produces some results, for example, analyzes some stock exchange data or market data, then it will not be regarded as technical at all, because it will be only an algorithmic processing. This even applies if we have some exchange with data. So my software reads data, analyzes these data, and that's it. This will be regarded as a simple algorithmic processing or as a mathematical processing, which is not technical and therefore cannot be patented. But if we move a step forward, and if the invention starts to interact with hardware, for example, there are certain accesses to memory, or some dedicated accesses to memory. You are using caches, for example. You are using some communication interfaces and the like. Think of these robots and machines that I've shown that communicate via an interface, for example, with a network. As soon as you are in this area, things will become technical. And these will be the technical parts where a patent could be focused on. There is another very good issue, and that's the input. So how, as soon as your invention interacts with hardware, and maybe this hardware even takes some inputs from an input device, like with this augmented or virtual reality system, things are again regarded as technical. You see, as close as you get to the individual underlying machines, the more technical you are, and the more or the higher there are chances that you'll get a patent granted. Similar applies to the output. The European Patent Office has said that kind of the normal output, which does not provide any further technical effect, is not regarded as technical. But Have a look at this one. This is a more sophisticated output in a virtual reality system. This would then again be regarded as a technical feature, which would be regarded or which would be acknowledged by the European Patent Office. So why making all these distinctions? Now some basics on patents. You will only get a patent if the features of the invention are novel and inventive. So a patent will not be granted on something which is already known. Sometimes I have clients, they come with an app and tell me, I have invented something with this app, and here's my website. And everything is written down on the website. That's a problem, because then you have disclosed the whole invention, and you will not get a patent. So patents are only granted for something which is new. It must not be disclosed. That's the first step. But we are not only granting patents on something which is new, but it has to be also inventive. This means that you'll get a patent on something which has at least some thoughts that exceed obvious measures. So something which would be normally do. And this is what we call inventive step or inventiveness. And the criteria for examining these two steps, or in particular inventiveness, they are only based on the technical features which I have here. So even if your software does something very smart, but this very smart stays completely within the running of the program and has no influence on the hardware, has no influence on the input or output, you will not get a patent, because it will only be examined with regard to the technical features. So that's the approach of the European Patent Office. And I would like to now go more into detail with regards to two very important technologies which are right now addressed quite often. And this is patenting of machine learning approaches or artificial intelligence first, and the second one is patenting of blockchain technology. I'm quite sure that you all know what artificial intelligence is, but I very much like to simply give some basic facts on these issues, or how we very often see that artificial intelligence can be summarized, or machine learning can be summarized. First of all, artificial intelligence is intelligence demonstrated by machines. We have a certain input, which is provided to an AI core, and the core inferences or derives a particular output. So that's basically it. That's artificial intelligence. Artificial intelligence is not intelligent at all. It is smart, I would say. Why it's not intelligent? Because this AI core has to be always trained for a particular task. Very often they are like, even researchers that talk about artificial intelligence being really intelligent and transferring knowledge from one domain to the other. But the current state is that we have to train artificial intelligence core for one dedicated task. As an example, we have, for example, a neural network, a machine learning approach, and then we feed this entire network with training data. This would, for example, be examples of dogs and cats. And then we train this artificial intelligence core for this dedicated task. After it has been trained, we can provide an input, again, dogs and cats, and the network will tell us, is this a dog or a cat? So that's basically what artificial intelligence does. It is very smart because we have a very increased amount of training data. We have a very increased amount of computing resources, and therefore the results generated are really astonishing. Think of autonomous driving or machine translations, or there are numerous examples, or analysis of huge data sets. But still, it relies on one particular dedicated configuration of the artificial intelligence core, which has been trained for this particular task. And if you ask the same artificial intelligence to provide an answer in a different domain, it will completely fail. But this is artificial intelligence. So you see, when you analyze it, what's artificial intelligence? Basically, it is only a processing which is done in software. So there's not really a huge need for any interaction with any hardware. Basically, not even an interaction with input and output data. Maybe with regard to training data, yes, there is something. So the European Patent Office acknowledged, however, that artificial intelligence is very important and that it is present in most innovations, and they have set up guidelines how artificial intelligence could be examined. And again, keep in mind this notion of computer-implemented inventions. And the European Patent Office said they have concluded some interesting ideas, where basically they said in the end that artificial intelligence and machine learning will be examined exactly the same way as computer-implemented inventions. What I think is completely right and correct is that artificial intelligence and machine learning are basically computational models and algorithms. Yes. And that these are per se of an abstract mathematical nature. So this means, again, we do not have technical details here. We have only some software processing, which basically will not be considered during the assessment of inventive step. They've also very well recognized that, for example, terms like a reasoning engine, neural network, that they are very often abstract models and algorithms, and that they therefore very often do not define such technical features. So first of all, it's a quite negative approach of the European Patent Office. However, the European Patent Office has recognized that as soon as you apply artificial intelligence in a field of technology, then it of course should be something which can be patented, and it is even something technical. One example that was provided is a heart monitoring apparatus. So using artificial intelligence to see how the heart works, yeah, let's put it like that. This was regarded as something technical. Furthermore, using artificial intelligence to classify images and videos, speech signals, on various levels, again was regarded as something technical, which I think is also completely all right and okay. And what's the most important and interesting thing is that even the training data has been regarded as something technical. So setting up the training data and training the artificial intelligence core has been regarded as technical, or is regarded as technical by the European Patent Office. This is particularly important because, as researchers in artificial intelligence know, the training data set is very important, and it's really difficult of getting the right data and setting up the right data. So this was kind of the more positive result that was given, and therefore artificial intelligence is clearly patented by the European Patent Office, and we see a huge amount of applications in this area. First of all, applying artificial intelligence for a particular technical purpose. So even if you have a very general neural network, let's put it like that, and you adopt this neural network to a particular task, you will get a patent granted on these issues. This may include selection and configuration of the training data, adapting of the learning approach, or even determination of the individual coefficients. But then again, what also can be patented is the underlying technology of artificial intelligence, like the machine learning approach or even the layout of the AI core. And what's always helpful is having a link to the technical area. So as you see, software in this area has been recognized as technical, and it is addressed by the European Patent Office. It can be patented, and it is not only protected by copyright protection. To another very important enabling technology, which we today see very often, this is blockchains. Briefly, a summary. I'm quite sure that you all know what a blockchain is, but nevertheless, blockchain is basically a technology that keeps records of transactions. Blockchains are very often compared to bitcoins or other cryptocurrencies, but they are, of course, not only cryptocurrencies. But blockchains may govern any kind of transactions that may be performed in the digital domain. And this is accomplished by establishing or by representing the transactions as data blocks, which are then arranged in chains. So that's the name for the blockchain, for the name. But there is another second very important aspect to blockchain technology, that these transactions are not verified by one centralized entity, For example, with currencies, a bank, which would say, yes, there have been a transaction of cash from party A to party B, but this transaction is governed in a decentralized manner, and this is very often also called a distributed ledger. So we have various entities in this blockchain network that each store and update a copy of the entire blockchain, keeping record of all the transactions that were happening there. And as soon as there is a new transaction to be recorded, this is submitted to the distributed ledger, which verifies the transaction and stores basically the transaction therein. Another important issue is that it's the construction of the blockchain, where these individual blockchains or the data blocks are bound to each other, so it cannot be corrupted. It is basically practically impossible to corrupt a blockchain by removing the individual transactions. So you see, using blockchains, you have a possibility to track transactions in a distributed environment that are the sole possibility of ensuring that there are individual entities which perform the transactions between each other. I already said it is not only cryptocurrencies. Here is another example. It's more fun, but I suggest that you have a look at it. It's CryptoKitties. I don't know if you have ever seen it. So researchers in cryptography, they grow their own CryptoKitties and they sell them online. And they use blockchains to guarantee that there is only one CryptoKitty and that this CryptoKitty is transferred, for example, from you to a different entity. So you see, not only cryptocurrencies, but also a lot of fun. So what can be patented with regards to blockchain technology? Again, it can be the application of blockchains to a technological area, or the modification or the adaptation of the blockchain technology for a particular technical purpose. This could be for identity authentication, product tagging, for example, drugs and food, or tracking of individual products. So different areas which can then be patented, or we have seen a number of patent applications directed at the underlying technology, such as cryptography, the public key infrastructure, the block construction, storage, maintenance in the distributed ledger, and the communication protocols. This is all regarded as patentable, and this is all addressed by the European Patent Office. Again, the link to technical area is highly recommendable. So this was one example. These were two important examples that we recognize right now in our daily practice. And so what's the important issue? And here I would like to provide you some advice or some insights when analyzing such software inventions or computer-implemented inventions. So I have said in this presentation maybe 1,000 times the word technical. And yes, this is one of the most important issues. When we analyze, for example, apps or pieces of software code, the first question is always what's the technical context? Is there any technical improvement? So does the computer work in a more efficient way? Can we save resources? Can huge amounts of data be handled, for example? This would be a technical improvement. Or is there a technical application area? Control of a robot, or as you have seen in this Apple application, 2 devices that enable copy and paste between the individual devices. Are there any technical or functional data? What is functional data? Basically data that control a certain processing in the computing device. So what we need from a perspective, or from what we need from a practical perspective when we patent software, we change the perspective. Because very often a developer has a look at the software or app and it solves a particular problem, and right now then you are digging into it and trying to establish whether there is some hardware network infrastructure which is optimized, accelerated, or secured, or if there are interactions with individual components, and very often this will completely change the focus. On the other hand, you will get a patent which then protects this piece of software code in a very wide and very good manner. So what does, for example, we as patent attorneys then know? need to know. We need more details, so be more specific. Simply saying that artificial intelligence has been used to perform a certain task is clearly not sufficient. We need concrete specifications or concrete definitions of the environment. Even what would be more interesting and helpful if we could somehow deconstruct the solutions and consider the elements separately. So all the data, all this information are needed. And then again, even with regard to inventors that have written some piece of software, it is important to see what technical problems are solved. And I already mentioned some examples of artificial intelligence where we would then dig into the model architecture, databases or annotations used from the training data, feature extraction, the training algorithms, or even the final trained model. But you see it's getting quite explicit with regard to how this training is being performed. So a complete change of perspective towards technical aspect, because that will be the underlying basis for patenting. So I'm now getting to the end of my presentation, and I would like to summarize before I present you some other interesting examples. Software relies on various IP rights. Traditionally, it has been protected using copyright, but there are other IP rights, intellectual property rights, and one of the most important is patents, because they protect the underlying ideas, and they do not rely on one particular implementation. So they should be always considered, but there's the difficulty that patents are granted only on technical inventions, and therefore the underlying technical concepts and ideas have to be extracted. The European Patent Office has a very well-established approach for examining so-called computer-implemented inventions. By the way, this is the European Patent Office, so it applies for European patents. Worldwide, we have different approaches, but I would say that mainly if a patent application is good with the European Patent Office, it will also survive with the other jurisdictions. I have presented some enabling technologies and what can be patented in these areas, and that's the practical advice. If you are trying to patenting, get the technical context. To conclude, I would like to demonstrate this kind of shift of innovation into the digital domain in one very classical and nice area, which is from Canon. Maybe you know this nice cameras in the hardware age. It was a very nice camera, 1971, and this was, according to Kenichi Nagasawa from Canon, patented using around 100 patents. Then in kind of the next age, the electronic age, the same camera, well, not the same camera, has been further developed, and more electronic components have been included, so the mechanical age has been left. And this was patented using around 1,000 patents. Now, you can imagine the next step. It's kind of the digital age, where the same camera has been connected with the network, or data has been further processed. And the same device, according to Canon, has now been protected using 10,000 patents. So, and now we are here, and I've omitted providing any number of patents. So we are in the area of Internet of Everything, or the Industry 4.0, where we even move further away from these devices towards smart devices, where the smart devices provide the general input and output. And it's all about the software that generates the improvements and that generates the further input. The patents are mainly related to software, interfaces, protocols, storage of data, and at this moment, Kenichi said that he was not able to determine the amount of patent that Canon has filed on these technologies. So you see, innovation is shifting. It's getting more towards software, and it's important to protect the software using the whole palette of, or the whole variety of intellectual property rights that we have. And well, you're encouraged to protect your respective inventions exactly using this palette of works. So that's it. Thank you very much. This will conclude my presentation. Oh, that's the wrong one. And of course, I'm here for any questions, and I'll be here in the afternoon for the software clinic. So if there should be any particular questions, please feel free to ask me, and we'll discuss these issues. So, questions. Thank you very much.
Thank you, Dr. Valvoda. But now, of course, are there any questions? We have a few minutes time, so if there's anything you would like to get maybe clarified. Okay. Yeah,
if
sure.
we have some minutes, I was wondering actually about the CryptoKitties.
Mm-hmm.
If it is if you know, Jakob, if it is patented, or in any case, if it could have been patented, that kind of software.
So CryptoKitties, patenting CryptoKitties. I don't think so. This was one example to show how what blockchains can be used for. But then, if somebody would be there and show me such an app or such a system, and telling me that he or she has now invented CryptoKitties and they would like to protect it, so we would then immediately start this analysis. If is there something new, or something that has been further solved in the piece of software that realizes the CryptoKitties? Were there any technical difficulties? And in this area, I would say maybe not, because it was an application of the standard blockchain technology to a nice idea, or I don't know if it's nice, but the people love it, so in the cryptography community. So it's not even a technical approach, or a technical application area. It's only trading kind of virtual goods, which don't even have a correspondence in the real world. It would be completely different if we would not talk about CryptoKitties as kind of aesthetic creations, but if we would talk maybe, for example, of tracking goods, for example, drugs. Even though the tracking of these goods is represented digitally as a kind of CryptoKitty, yeah? They have a direct correspondence in the real world. So there's a drug which is shipped on the market or somewhere on the market. And this is a digital twin in the virtual domain. So this digital twin then directly corresponds to some real objects. And then it would be different. So CryptoKitties, I think, no. It's only a nice idea. So no patents in this area, I can't imagine. But these would be then the question how to dig inside and to get the technical context. Thank you.
Thank you. Now we have another question down the hall.
I'm Martin from Josef Stefan Institute. Just a question regarding global protection with WIPO, World Intellectual Property Organization. I was wondering if they have any different views from the European Patent Office, and what would you maybe recommend in terms of global protection or more regional?
Okay, thank you very much. So the question was directed at WIPO, so meaning international PCT applications. The WIPO does not examine or even search any applications. It uses the local patent offices, for example, the European Patent Office, for conducting the search. And in the end, also PCT application and international application has to be nationalized in all jurisdictions, national states or regional states. And they will then examine individually the application. So there is not an approach of the WIPO. If you, as Europeans, file an application with the WIPO, it will be searched by the European Patent Office, and then the European Patent Office will apply their approaches, and they will also provide a preliminary search opinion with the search, and this will be based on what I said, based on the approach of the European Patent Office. It would be completely different if the international application is searched by the Korean Patent Office, or if it is searched by the USPTO, so the US Patent and Trademark Office. So I hope this answers your question. It will always depend, because the PCT application, the international application, is only an administrative process which kind of enables patenting worldwide, but still it's only an option, and in the end you will have to decide in which countries you would like to obtain a patent, and the law of this kind of target country will be applicable to the application in the end.
Thank you. Now we have 2 more questions.
Is there any progress in the European Patent Office or WIPO concerning this conservative approach about between the computer implemented dimension and USA patent is declared in Europe or in WIPO as a business model.
Mm-hmm.
So is there within last 5 years any approach from the WIPO or EPO concerning is that business model or is that a kind of computer implemented dimension?
Okay.
I have this experience.
Okay.
Bad experience.
I can confirm your bad experience, and there is no change at all with regard to business methods. The European Patent Office will not grant patents on business methods. They will be completely excluded. But it applies the exactly same approach as I've presented here, applies also to business methods, basically. The European Patent Office will have a look at the business method and try to establish whether there are any technical features. And again, how is the business method implemented? What kind of hardware does the business method require? What kind of input or output does the business method require? Are there any technical problems solved by the business method? And then a patent could be granted on this focus or dedicated area, but not on the business method. So you will never get, in my opinion, you will never get a patent granted on the business method by the European Patent Office. By the way, this has changed even in the US. So at the moment, I would not even recommend filing applications in the US where you think that you have a business method which should be granted in the US. Jurisdiction has changed, or case law has changed a lot. And right now we are encountering massive problems in the US with regard to abstract ideas, so-called abstract ideas. And these patents are also rejected in the US. So I would say that also the USPTO has chosen a slightly corrective approach where they are maybe even moving in a similar direction as the European Patent Office. And by the way, as the Chinese Patent Office, CNIPO, and Japanese Patent Office. So all these abstract considerations, for example, a business method, or even in software, like purely some algorithmic considerations, are disregarded, and it's only patents are granted on the underlying technical concepts. And I don't even expect that there will be some progress. But what's more interesting in this area is that there is significant process in machine learning and artificial intelligence. I know that the European Patent Office is conducting auditions with applicants that file applications in artificial intelligence, and that they are even more closely trying to establish what this or the importance of this technology. And maybe we will have even some further development in the guidelines with regard to artificial intelligence. But I'm sorry, not with regard to business methods. No.
Thank you. We have time for one more question. Okay, the last one, and then any other questions you can ask Dr. Valvoda during the breaks or later on in the afternoon.
Thank you. My question is, let's, for example, that you take one algorithm which is very computationally intensive, so only doing some data stuff, so I guess this is not patentable. But then you adapt this algorithm for some other architecture, like supercomputer or something very different, where you have to exploit many technical details and so on, do a lot of engineering. Is this patentable or is not?
Well, basically, you answered your question. If you put it on if I understood you correctly, is that we take a computational intensive algorithm and we implement it on a particular computing system. So basically, make it can run. Yeah. So.
Yes, you take an existing algorithm which is like something very simple, on classical architecture, but then you adapt it on very different architecture where you have to exploit many. You mentioned the cache hierarchy or something like that.
Yes. So the implementation would be technical, clearly. Even though the algorithm is known, you implement it on a system, and you provide a technical solution. You define how this can be implemented on a piece of hardware, which is not only a piece of hardware, but you use maybe caches, maybe different cores, and whatever. So you say how this can be implemented, and this is technical. So this will be taken into consideration. But then the EPO will then start the examination with regard to novelty and inventive step. So, and first of all, you said that the algorithm is known. So the algorithm as such will not be regarded, so it will be not taken into consideration. It's just something which is, I would say, in the public domain, so it's known. And then there is the question whether this particular implementation is inventive, or whether it was suggested maybe by already existing works. So, but this is the examination of the inventive step. Okay, and this will then depend on, or this will then clearly determine the result, whether a patent can be granted or not. So I would say technical features, yes, this is the technical implementation, but it would even be more the question of an inventive step, whether this technical implementation is sufficient for the European Patent Office to grant a patent. Okay, so thank you.